Yeah, hi everyone. So my name is Yash. I'm from Mumbai. I'm currently working at Asian Paints as a data and analytics engineer from past 2 years, and this is my first job actually. So yeah, I have been working on multiple functions. I have experience in supply chain, commercial, finance. In the past 2 years, I have worked in almost all the departments of Asian Paints in the analytics domain. And I have been mostly currently working on Power BI, Synapse Analytics Stack, Azure. I have been doing data engineering using ADF as well, but we have some restrictions in our organization, so we are not able to use completely ADF. And we have our legacy platforms as well, and we mostly use SAP Analytics Stack for data analytics. So SAP BW and SAC Analytics Cloud are the most used tools which we use, and I have been working on those extensively.
Thanks, Yash, for your intro. Jeet, can you report yourself? Ajit, can you hear us? You can unmute and speak.
Hello.
Yeah,
Yeah.
you can go ahead. I'll start with Abhirendra.
Yeah, I have to introduce myself, Azit.
Yes, yeah.
I just joined, so okay. So I am Dhirendra. I am working in TCS as delivery partner, having more than 18 years of experience. And you can say, this current role as a delivery head. And due to the organization shuffling, I got a new, cluster that is for AI cloud and AWS and Azure cloud, and that's why I just wanted to have some data-related understanding about AWS, so that I can have more clear visibility about the project running. That's why my objective.
Great. Thanks, Dheeraj.
Yeah.
And Bharadwaj, can you brief about yourself?
Hello.
Can I?
Yeah, Bharadwaj, you can go ahead.
Yes. So this is Bharadwaj. So I'm service delivery associate working in Fujitsu Consulting India, Hyderabad location. So I come to know this advertisement in Facebook. So I just tapped in WhatsApp. So I come to know this meeting invitation.
Okay, got it. And Sai Krishna?
Hi, I am Sai Krishna. I have already worked in Power BI in Bangalore location, Bangalore. I saw advertisement in Instagram, so I learned about the data engineering, AWS data engineering. That's all.
And Suresh?
Yeah, hi, Ganesh and Aditya. So myself, Suresh, engineer in cloud and DevOps. Now I'm working as an operations manager, maintaining all the infrastructure and the DevOps pipeline. So my expectation from this course would be to, at the end of the course, would be to be, I should be able to migrate the data as well as the both the batch as well as the streaming kind of data. So I should be able to write the Spark jobs as well as the integrating the Lambda. So after seeing the course description and the document which I've gone through, so I thought of taking the demo once. I hope. I mean, whatever been there in the document, like if I get like my expectation will be fulfilled.
Thanks, Suresh. And Ajit?
Yeah, I'm Azit. Currently, I'm working in HCL. Few months ago, I have done with my project. Now I'm completely on bench. Yeah, I'm looking for a course that which can help me to enhance my career in the data engineering field. I'm looking for a very good content in data engineering. Yeah, that is why I joined here.
Okay, thanks, Ajit.
Thank
It's
you.
a couple of folks others joining.
Sairam. Sairam, can you brief about yourself? I think he's not yet joined with audio. Yeah. Vamshi, can you brief about yourself? Vamshi, you can unmute yourself.
Hello.
Yeah,
Hello.
can you brief about yourself?
Yes, sure. So basically, I'm a Snowflake data engineer and I'm having a total 9 years of IT experience. So I wanted to switch my profile to like AWS data engineer. So that's the basic motto of joining the course. And yeah, even I wanted to basically, I mean, since I'm having a knowledge on machine learning and deep learning, so I wanted to basically enhance my skill set, and that's all. Hello.
Okay, thanks, Vamshi.
Yeah, Aditya, you can go ahead.
Thanks everyone for your quick round of introduction. Welcome everyone to the first demo session. My name is Aditya. I'm working as a senior data engineer and ML engineer in a Fortune 10 organization. I have 8 years of experience into this domain. I started my career as an Informatica developer and then gradually shifted to cloud data engineering. And since then, I'm predominantly working on AWS as data engineer and ML engineering. And currently, my roles and responsibilities revolving around how do I get the better source of data? What are the best strategies to build data infrastructure? And how do we enable data scientists to run ML models? That's what I do in my day-to-day life currently. I'm very passionate about data and I want to teach more and more about the data because this is the growing industry. This is the growing space, right? Not many folks know what is the potential of this area, and I want to, you know, uh, guide people. I want to coach people in this domain so that they can excel and ride the wave of data engineering in general, right? So that's a bit quick round about me. Right. Let me quickly, talk about what exactly data engineering is. And this demo session is divided into two parts. One is the basics of data engineering, why we are here. And second is a quick short demos that I have planned for you for batch processing and streaming processing that will go through it at the end of the session as well. Right. Okay. I'll quickly share my screen. Okay. I'm sharing my screen. Just confirm if you guys are able to see my screen.
Yes.
Okay, thanks everyone for the confirmation, right? So what exactly data engineering is all about, right? So the course that we are going to discuss today is basically about data engineering and predominantly on AWS, right? But before we, go deep dive further, what AWS is, what are the technologies are, first of all, let's try to break the myth, what exactly data engineering is, right? So first of all, to understand data engineering, we need to understand what exactly data is, right? So data is anything that we produce every day, right? In any shape and form, starting from a transaction that we are doing on our card, credit card or debit card, or uploading a photo on Instagram or Facebook, right? Anything that we do nowadays in one way or the another contributes to newer amount of data that we generate over the period of time, right? If I just have to give you one stat, the amount of data that we were generating in 2012, right, in a year is equivalent to the amount of data that we generate today within a single day itself, right? Imagine the year worth of data that we generate 10 years, 12 years back, the same amount of data we generate today in one day itself, right? So which means that there is loads of data available there, and there are people and there are organizations who are very much crazy about using this data because this data is the new gold in this digital era, right? With the help of this data, business can take informed decisions, right? They can make sure that their businesses are profitable in nature, right? I'll give you one example of Walmart, right? Everyone knows about Walmart. Walmart is a retail chain, right? That do business by selling products at a cheaper rate in volume so that people buy from there. And they are the world largest retail company today in the market. If I talk about in terms of revenue as well, they are the world largest, right? They generate tons and tons of data. How do they use data, right? I'll give you one basic example of how Walmart is like to use the data, right? Let's say Walmart has a store in Bangalore already, and it's been running from last 5-6 years, right? Let's suppose that, right? People buy products from Walmart, right? And Walmart gets this data, and everything is working fine. Now Walmart wants to launch a new store in Mumbai, right? So if they want to launch the store, they want to understand that what is the buying pattern of Indian people, right? So how do they find out the buying pattern? So what they can do is they can look at the Bangalore purchase history data, meaning they will say, okay, over the past 5 years, which products normally sell well in Bangalore, right? For example, in Bangalore, people buy more fast commerce products, right? Similarly, if they have to open the store in Mumbai, they can use the data generated by Bangalore over a period of 5 years. They can easily get the insight and they can place the products in Mumbai store so that the Mumbai store can become profitable from day one. Imagine in Mumbai, you are selling winter clothes. Does it make sense? No. Mumbai is never a hot climate, right? This is one example that I'm giving. We all know it's very obvious, but similarly, there are a lot of data patterns that are hidden to human eyes that can only be find out after, masking this data, after rubbing this data, after analyzing this data. And how do you analyze large scale data? How do you make sure that the data is in right format so that right machine learning model, right analytics can be run on top of it, right? Who provides this data to analytics model, who provides this data to ML engineer so that they can get insights out of it, right? So this is the responsibility of a data engineer, right? Data engineer play a very important role in making sure that the data that is available out there, right? Raw data, structured data, and structured data that is available out there, to make sure that the data should be in a right format, that data should be in a right shape so that right machine learning models, right analytics, right BI can be built out of it, right? And how they do it? By using different tools and techniques available at our disposal. For example, building data pipelines, by using different cloud infrastructures, by using different tools like Informatica, Alteryx, Azure, Databricks, Snowflake, so on and so forth. So that's what, in general, basically data is all about. That in general, basically data engineering is all about. That's basically in general what a data engineer is, right? I'll quickly shift to a second topic that we have, which is what exactly data engineering, right? In detail, right? We have understood from the story that we have listened that data is there with which we can generate a lot of insights. But how do you generate insights out of this data, right? So as a data engineer, or in the terms of data engineering, you will be responsible of building and maintaining the infrastructure that can hold large scale data, meaning you have terabytes of data available out there, but where do you store that information, right? What is your infrastructure to store that information? Similarly, what is your infrastructure to process this large scale data? How will you process streaming data that is coming very fast to you, right? How will you handle Instagram reels? How will you handle tweets coming on Twitter? That is what all about data engineering, right? Now, in terms of the responsibility of data engineer, so data engineer is responsible of collecting data from various sources. What exactly it means? It means collecting the data from a file, collecting the data from a database, collecting the data from the website, collecting the data from a fast moving Kafka topic, right? All of these are basic responsibility of data engineer. Post that, what exactly data engineer do? It transform the data so that data can be bring in a right shape. Post that, a BI can be built on top of it. Analytics can be run on top of it, right? Or basically business is able to understand and take informative decisions out of that data. That is what a basic responsibility of data engineering is, right? What challenges data engineers normal faces? It's all about scalability. It's all about the large scale data. It's all about how fast you process this data. It's all about the data modeling, lot of things that data engineer faces in general. And we are going to discuss all of these things in detail in our sessions that are planned, right? Okay, that is what about data engineering in general, right? Now we have this term, right? AWS data engineering. So what exactly AWS is, right? So to understand AWS, first of all, we need to understand what exactly cloud is, right? So the picture that you see with the red border is not the cloud that we are going to discuss, right, today. The cloud that we are going to discuss is this picture with the green border in it, right? So cloud is nothing but a set of machines or computer that are way beyond our reach, that are kept in very secure, safe locations that humans cannot directly interact with, but clouds are basically used to store and process our data, right? One simplest example of cloud that everyone has used in their life one way or the other, another is Google Drive, right? I hope everyone has used Google Drive. Google Drive is one of the best, simplest example of cloud, which means that you have some files, photos, video that you want to store for longer. You put those photos and videos in Google Drive, right? And once you upload those videos and photo in Google Drive, they are secured in the cloud server itself. Meaning, let's say if your phone is lost, if you forgot the password, if you password of your phone, or let's say if you lost your phone or your phone is broken, you can log into the same Google Drive through a different device, let's say from a laptop or maybe any part of the world. You can log in and you can get access to your important data that you have already secured over the cloud itself, right? Similarly, think of a scenario that there is a bank who has all the millions customer data in a bank server. Imagine there is a flood happened at bank location, and because of that flood, the server is no longer available, which means that all the data belonging to the customer, their bank balance, their bank account is gone, right? Do you accept this kind of situation to be happen in real world? No, nobody will accept, right? That's why bank keep their backups in the cloud, which means that once the data is available in the cloud, it can never be stolen, it can never be wiped out in just a jiffy because of a natural calamity or because of any unknown activity, right? So you can keep safe and secure your data over the cloud itself, right? Now the second question is why this course is predominantly built on AWS itself, right? Why not other clouds? Because we have used the most common cloud is Google Drive. So why we are not talking about Google as a cloud service? Because in professional world, if you look at the chart on my right hand side, AWS is leading the cloud market in professional worlds, which means that all the organizations prefer AWS as their primary cloud compared to all the cloud available in the market, right? What other clouds do we have in the market? We have Azure as one of the cloud. We have Google Cloud as one of the cloud. We have, cloud from IBM, Salesforce, Oracle, and so on and so forth. But if you look at the market share of AWS, it's 32% and it's growing since then, right? This is the stats that we have taken from Q1 2023 and we are in Q2 2024, and this stat has grown further since the time the stat has been captured, which means that AWS is the leading cloud provider in the market, and hence this course has been designed to make sure that you are learning things that are very popular in the market so that your adaptability to the market becomes more and more, right? Okay, now what exactly AWS cloud computing is, right? So to understand AWS cloud computing, let's understand this from an example. Okay, so you are planning to go on a trip to a different country and you want to stay there for 1 month, right? And as part of the vacations, you are going to travel from one place to another in that country. And the plan is you want to travel through a car, right? Because public transport, you don't know how to deal with that. So you want to travel through car. Now there are two options. One option is you go in that country, you purchase a new car over there, you buy the insurance, you pay all the registration fees, right? You make sure that all the fee related to a car you are paying. you are going to use that car over there for 1 month. And the problem is you cannot take the car back to your home country, which is India. You have to keep the car over there itself, and you won't be going to use it post that. So which means that in all, you are going to use the car only for 1 month. All right. Second case is you go over there, you go to a renting company who is renting the car for the duration you want to use it. For example, the terms and condition is you have to pay per hour cost for renting the car. If you want to use the car for 30 days, you are going to pay 30 days money for that car users only. And there is no headache of maintaining the insurance. There is no headache of maintaining the registration charges. Everything the rental company will make sure they will pay the money for everything, all in all, right? So which option in your opinion will you be choosing if you are going on a trip? Option number one, where you buy a new car. Option number two, where you rent a car. You can unmute yourself and speak.
Maybe the rental.
Okay. Okay. Why you want to go with rental? That's a good option, but
Because we'll be paying only for the time that we use.
perfect. Perfect. And if you go with buying a car, then the headache of maintaining the car will be on your shoulder itself. Correct? Everyone agrees with this point?
Yes, sir.
Perfect. Right. So same thing happens with cloud computing as well, right? So normally, typically, let's assume that when a company started, they had, let's talk about an example of Netflix, right? So Netflix started back in 2006, right? Everyone knows what Netflix is. Netflix is a company that allows you to watch movies, TV shows, right? Back in 2006, when they started as a replacement for VCR, right? Everyone may be knowing what exactly VCR is. VCR is a CD similar like device where you can watch with the help of that, you can watch the movies, right? Typically, people rent the VCRs and they can watch the movie at their leisure time, right? So back in 2006-7, that is one of the good market where people allow you to rent the VCR and people pay for that renting money, right? Then Netflix came at that time and Netflix uploaded all these videos over the internet. And you know what Netflix said? Instead of coming to the store, buy the cassettes, pay the money, you can do it only at half of the price. We have uploaded all the videos, all the movies on the Netflix platform. You can go over there, pay some money and watch those movies. You need not to come to the store, right? So when they started, they uploaded very small number of movies, right? So since they are uploading movies, they need some server, right? Where they are going to store those movies. So they typically buy some servers, right? And what those servers are? Servers typically look something like this. I'll show you. Servers look something like this. These are racks, computer racks. Everyone may have seen one way or the other these servers. Netflix maintains these servers initially, right? They uploaded some movies and video, and people were, Netflix website, and they were watching these videos in general, right? Now, what happened? The demand of Netflix has increased many folds. They have to upload a lot of movies and videos just to make sure that their customer who are paying money would be retained, right? Because there are a lot of new movies coming in, and they want to make sure that whatever movies and TV series are coming in, their customer should only watch these movies from Netflix platform only. So they have to upload a lot many videos and TV shows. Now they are running short of servers because these servers are very costly in nature. They have to buy the server, right? Then they upload the movie, and post that they have to maintain these server, meaning these server get hot very quickly, right? So they have to make sure that these servers are very cold in nature. They have to maintain ACs, infrastructure. They have to maintain a team who are constantly upgrading the servers, maintaining the server, that if anything is happening, the team is replacing these servers. So a lot of headaches Netflix has to manage. And since the size of this data has grown many-fold, they have to buy a lot and lot of costly servers, and whenever a server is malfunctioned, they have to replace the server with a new server, and that costs massively, right? That costs massively. They have to pay a lot of money to their support team to maintain these server. They are paying a lot of money to make sure that the servers are cool. Can you please unmute yourself? You're not asking any question. Yeah, thank you. Right, so they are paying a lot of money. So as an alternative, right, what AWS says to them, right? The AWS says, hey, you are buying a lot of servers, you are paying a lot of money, you are paying a lot of money to hire the talent to. Can you please unmute yourself? Ganesh, can you unmute the team if they are not speaking? Okay, thank you. Right. So what AWS says to Netflix is, hey, we realize you have a problem of maintaining these servers. We have a huge servers that you can rent from us, right? You need not to worry about the maintenance of the server. You need not to worry about who is going to cool down these servers. You need not to hire a team to manage the server. What you need to do is just come to AWS S3, which is a storage service. You upload your videos over there, right? And we are going to take care of everything. Just pay the money for the time you are uploading, or are going to keep the videos over there. Netflix was like, wow, you solved a lot of our problems. Now we can focus more on customer rather than focusing on the infrastructure, right? And since then, Netflix is one of the major contributor, or one of the biggest customer of AWS that uses AWS services, right? Since then itself. So that's how cloud computing helps. That's how cloud computing help businesses. Similarly, if a business want to run a new project that needs high amount of GPU and CPU, right? Nowadays, everyone knows about Chat, GPT, AI and all. To run these kind of models, you need a lot of computing power. You need a lot of GPU, CPU, so on and so forth. These are very costly in nature. They cost, no short of millions if you want to run a high-end model. So the one option is go buy that infrastructure from the market, set up this infrastructure locally, hire a team who is managing this infrastructure, and then do some experiments. Let's say your experiment is done for 6 months and you no longer want to do anything post that, right? So you are burdened with all of these infrastructure at your head. Rather than, what you can do is go to cloud, ask, hey, give me some compute power where I can run large amount of GPU and CPU, right? Pay for those 3-4 months till your experiment is done. And once you are done, just, go away, right? Nobody will ask for any money extra apart from this. So that's the benefit of cloud computing, right? It's pay as you go. The work you want to do, you want to pay for that money only. No extra money is involved, no money to buy that heavy, bulky infrastructure, heavy, bulky servers, right? So that's all about a simplest overview of cloud computing and how AWS is helping businesses in doing this cloud computing. They solve the problem of infrastructure, they solve the problem of money, they solve the problem of serviceability, and so on and so forth. Right? A lot of problems AWS cloud computing solve to businesses to run their work, right? Okay, now I'll quickly talk about what exactly we have planned in our course, right? So these are different topics that we have planned. We are going to talk about SQLs, basics and Python. We are going to talk about Spark, PySpark, AWS services, right? And real world AWS projects, case studies, all of these are planned in our course, right? Okay. I'll quickly shift your focus to a quick demos that we have planned, right? One on streaming pipeline case and one on a batch processing pipeline case, right? I'll quickly switch over my screen. Just give me a sec. Okay. I hope my screen is visible again. Okay. So what we are going to do is, guys, we are going to build a quick streaming pipeline. And what that pipeline is going to do is, basically we have a database, right? We have information coming, from a bank. Let's suppose there is a transaction happening where a customer is opening a new account, right? So this information is coming through the bank, and this information is going to land in this database in real time, right? Everything is going to happen. Let's say this is customer information, and this is going to land in this database in real time. How this is going to happen, I'll quickly show a basic overview of the architecture. So we have this app who is generating the real-time transactions. This app is basically is interacting with a SQS, which is nothing but a AWS service that we are going to cover in detail in our future sections, right? This is an SQS. This SQS is linked with a Lambda, right? Need not to worry, right? These words as of now may look aliens to you, but when we go forward in our sessions, right, in future, you will be going to learn each and every aspect of these things, with practical use case, hands-on use case, everything. Right. And then lastly, this is going to load this customer information in this database, and everything, guys, will happen in less than a second. Everything will happen in less than a second itself. Right. Okay. So this is the basic architecture of this process that we want to show, right, that we have in built. Right. And let me show you. Right. So let me go to, first of all, database, so that we can see whether we have a record or not. I hope this DB is visible, right? This is DynamoDB that we are using in AWS. It contains one record, right? Let me run this. It contains one record. Let me do one thing. Let me delete this record so that we can load a fresh record in this. Okay, right? This DB doesn't contain any record, right? Now let's do one thing. Let's put one message in an SQS queue, right? This is an SQS queue. We are putting one message. So we are putting an ID, we are putting the name of a customer, and we are putting the age of a customer, right? Let's do one thing. Let's send this message. Okay, our message has been sent. This message is being picked by a Lambda function. This is the Lambda function who is picking this message. We can see the same information in the logs. Okay, we see a log created just now. This time is in UTC format, right? And if I go to the logs, you will see the same information in the log, right? Same record. And if I go back to the DB, if I run this, it should show me the record, right? And that's it. So we got the same record added in the DB. And not only that, we have added one more column, which is called is adult. Basically, we are checking if the customer is a minor or if it's a adult, right? And since the age of this customer is more than 18, so we are saying the customer is a adult. We are adding the flag. So automatically happens on the fly in less than a second itself, right? Let me give you one more demo. Let me add something else. Let me add 1, 2, 3 as an ID, and let's add something else. John Doe, and let's say the age is 12, right? If I send this message is done. Let's go back to this DB, and that's it, right? In less than a second itself, one more record added, and this time it says it's not an adult. It says it's false. Why? Because the age is less than 18 itself, right? So everything happens in less than 1 second. How this is happening? This is happening because of the infrastructure, the architecture that we have built. It's nothing but a streaming pipeline that we have built, which is using AWS services to process this data, right? Transforming this data and then finally loading this data back to a database itself. This is one basic demo of a streaming pipeline, right? When we go in our course, there will be more real-time projects focused on these streaming pipeline use cases, where we will talk about how in real world these streaming pipelines are being built, right? There are more to it that we will show. Now I'll talk about one more thing, which is a batch pipeline, where we are going to read a file, right? After we read a file, we are going to perform some analytics, and then we are going to build some graphs out of it, right? So this is Databricks that I am using to process a batch pipeline. Basically, I'm going to read a big file, right? And in our course as well, we are going to discuss about Databricks, in the future sections. Okay, let me do one thing. Let me read a file, right? So I am basically reading a file. Let me show you the output. So it's a big file. It contains more than 10 lakh records. This is the file that we have. It's basically a Google ClickSense data. Those who don't know what is Google ClickSense data, basically every website that is there online, you can allow Google to crawl and track how the users are behaving to that website. For example, if I, let's say, go to any online shopping site, maybe let's say Amazon, right? Let's say if I open Amazon, let's open in a new tab, Amazon dot in. Okay, so if I go to Amazon, let's say if I am clicking on refrigerators, right? Let's say I'm adding this refrigerator to cart, right? I have added this refrigerator to a cart, but I then close this website, which means that I didn't make the purchase fully, right? So if you enable a feature in Google Marketing, it is called website click sense tracking, which means that every click a user is making, the Google is tracking each click and storing this information with itself, and finally you can see the overall result for a day, meaning how many users logged into the website, how they interacted with the website, how many users actually added something to the cart, how many users have made the purchase, so on and so forth, so that you can understand how the traffic is coming on your website, right? So same information we have with us, right? It's a data coming from Google ClickSense for an e-commerce website. You can see, right? And these are the different events. And this column, device column, basically talks about with which device the user has logged in. For example, if the Google ClickSense is enabled on Amazon, in that case, it will show that Windows user has logged into Amazon and added something to the cart, right? Similarly, if I have logged in through Mac, it will show Mac as device, so on and so forth, right? And few other information like if the user has made any purchase, what is the value of that purchase, right? When the user has logged in, which location the user is logging in, right? With city and state, all of this information Google knows and Google capture this information so that business can take more informed decision, right? Same data that we have here. So as a marketing manager, the manager wants to know that with which device, right, we are getting more revenue. For example, are we getting revenue from iPhones, like people logging through iPhone purchasing more, or are we getting revenue from people who are, logging through Android phones, or we are getting revenue through people who are logging through Mac OS, basically, right? Or people, we are getting more revenue if they are logging from a Windows operating system. Like which device type we are getting more revenue? If I want to understand this information, I can simply build a basic pipeline using Spark, right? I'm using PySpark to build this pipeline, and if I run this query will give me a result saying that which device gives you more revenue, right? Let the query be run. Okay, and you can see here, if I just sort this on the basis of revenue, I can see that Android is giving me more revenue, followed by Mac, iOS, Windows, Linux, and Chrome OS. I have a graph here as well depicting the same, and you can see that Android is clearly winning the race. Like we are getting maximum revenue from Android, followed by Mac, and the least revenue is coming from an operating system called Chrome. Instead of device, I can do the same analysis using traffic source. So if you look here, we have a column called traffic source. So what exactly mean by traffic sources? From where the traffic is mainly coming. Like if a user is coming through Google, if a user is coming through Facebook by clicking the ad of Facebook, if the user is coming by clicking the ad on Instagram, if the user is directly coming by logging to the website itself, how the user is coming, right? If I want to understand the revenue from different sources, I can simply run this query and this query will give me my answer. Okay, and we got our answer. So if I just sort this on the basis of revenue, I can see that most of the revenue is coming from email marketing, followed by Google, Facebook, Instagram, so on and so forth. I can see the same in the form of a graph, right? This graph is no longer visible anymore because we have changed the column name. I can edit this graph and I can get the same information. That's it. It's not device anymore. It should be traffic source. Perfect. right? I save this, and you can clearly see that email is winning. From email, we are getting the most revenue, followed by Google, and the least revenue we are getting probably from YouTube, right? That's what it is, right? So this is two different type of pipelines that we have. One is batch, one is streaming, right? I'll take a just quick pause to see if there is any question from you guys on these similar lines. You can unmute yourself and ask questions.
Hi, Aditya. Yes, yes, sir.
Yeah, hi Yash.
Hello, sir. Are you going to teach us how to
Sorry, can you please speak one by one
Spark
one by
jobs
can you
and
please speak
the
one by
creating
one?
the pipelines for automation?
I'm not getting the question. Can you please speak one by one? Please go ahead.
Sairam, you can go ahead. Or anyone?
Yeah, yes, yes, sir.
Yeah,
Am I
Yash.
audible? Am I audible?
Yeah, you are audible, Yash.
I know it's Suresh. Yeah, Suresh.
Yes, sir, Suresh.
You go on.
So what I'm saying is like, would you teach us the Lambda, how to write the Lambda functions as
Yes,
well as
yes,
the
everything.
Spark jobs using PySpark?
Yes.
And the
Okay, what I understood is you are asking that are we going to teach Spark, Lambda and everything, right? I'll quickly go back to the core structure. Uh, okay, so the core structure is like this. So we are going to talk about basics of SQLs in Python. What is Spark? What is PySpark, right? Everything will be hands-on, right? Nothing will be theory. Like obviously there will be basic knowledge of every topic, but everything will be hands-on in nature, right? So that you can practice, you can learn what are the real world industry application of each and every aspect of this course, right? Nothing will be, given only in theory format. Everything will be fully hands-on and with respect to the industry standards. And if I want to go in very deep of each topic, then with respect to tools, these are the different tools that we are going to cover, right? We are going to cover AWS as our main tool. Then we are going to cover Spark, PySpark, right? Databricks is going to be our tool. Airflow is going to be our tool. Snowflake will be as bonus tools in this course, right? If I go further deep, right, these are different topics that we are going to cover for each element, right? What is Spark? Similarly for PySpark, similarly for Airflow, right? S3, Kinesis, Lambda, Redshift, right? Everything will be covered during this course, right? There will be a lot of case studies that we are going to discuss while we reach the end of our course, and everything is well planned in this course. So by the end of this course, I can show you what you will be, building, right? So you will be building some projects and architecture, something like this, right? This is one basic architecture of one real-time projects that you're going to build by the end of this course. So this will be given when you reach that stage, right? So all of this is well planned in this course and it is very well structured. I hope this answers your question.
Yeah, thank you.
Yeah.
Hello.
Yeah.
Hey, Aditya, Vamsi here. So basically, I wanted to understand one thing. So what is the life cycle of it? I mean, what is basically life cycle of data engineering? Could you please throw some light on that?
Can you please elaborate the life cycle word? I'm not fully getting like what exactly this
No,
life cycle.
a life cycle as in, like okay. So for in the first demo that you have shown, it's basically the streamline,
Mm-hmm.
basically the real-time replication, I would say.
Mm-hmm.
And the second demo which you have shared, it's basically called as some batch job execution, if I'm not
True.
wrong.
True.
Yeah. So a life cycle as in, like, first there will be some ETL kind of tools and which will be used to replicate the data. And second thing, for after we get the data, we basically deal with structured data, unstructured data, and semi-structured data. So are we going to do some cleaning as well? Like, I
Yes.
mean, what are the base things that are going to be done in a life cycle? Like, as soon as we get the data, do we go to the data warehousing tool like Redshift or something like that? Or what is the significance of having AWS Athena or AWS uh, DynamoDB as such? That's what I meant. Like,
Okay.
in a project, what is the total life cycle?
Okay.
What is the sequence? I
Okay.
meant to say.
Okay. So if I'll show some lights, right? The things that we have planned is, so we are going to build a data lake, very similar to Netflix. Why I'm using Netflix in this uh, uh, example is because Netflix is one of the pioneers in data engineering, right? Everyone will agree to that. They are the inventor of iceberg tables. They are inventors of a Parquet. A lot many things they have invented during the course. That's why we are going to see how much we can relate to it. So we are going to build a data lake very similar to Netflix, where we will be having a raw layer. We will be having a bronze layer. We will be having a silver layer. We will be having a gold layer. So what these layers are? These layers are the different data sets that you have at different points in time, meaning you will be getting data from various sources. So can I load that data directly to a target? No. I need to place this data into some temporarily layer. That layer probably be our staging, or you can call it as a bronze layer. Post that, there will be cleaning, there will be standardization, there will be lot of rubbing of the data depending upon how the data is coming. If it's a streaming, how we handle streaming, there will be different stages to handle streaming. If it's a batch processing, then there will be different stages to handle that batch processing. So all of this is going to be covered in the course as we move along, right? So I'll start basically with S3, then I'll talk about why S3, right? Why we cannot directly use a database, why we want to use S3 in the first place, how we are going to integrate S3 with different tools and technologies available within AWS and outside AWS as well. Say Snowflake, say Databricks. Why we want to integrate, right? Why cannot I directly load data to Snowflake itself? Why I want to bring into S3 first? So all of this we are going to cover in this course, where we talk about the full life cycle of our data engineering. I hope this answers your question.
Yeah.
Okay. Great. Okay. Any other question, guys?
Suresh, Sai Krishna, Ritvik.
Yeah, just one simple question. Yeah, Aditya. Once we learn all this and work on our projects, how are we going to showcase our projects in our resume or what? I don't think cloud pipelines. We will be able to attach the link to cloud pipelines to our GitHub.
What I understood is how you are going to show these
Yeah.
learnings in your resume, and how you're going to, defend these while doing to the interview, right? So there will be real-time projects that we are going to cover, and every topic that you're going to cover will be revolving around the real-time uses of it. For example, Lambda. When we discuss Lambda, it's not going to be only theory, like, okay, what Lambda is, what its uses. We'll see how Lambda used in industry. What are the various use cases of a Lambda function when you work on a real-time project? If you want to use Lambda for a data engineering pipeline, in what cases you want to use? In what cases Lambda is not a real fit for data engineering pipelines? All of this we are going to cover and discuss in the course. Now talking about the projects. So there will be two projects, right, that we are going to discuss, and you can use these projects and you can talk about these projects, right? So for example, you are working for a XYZ company. So accordingly, you can talk about the project with those company standards in name, right? Because these projects are very generic in nature. I cannot map it to a specific company because every individual is working in a different company. So they want to use it in their a company domain, and then they come up with the story around, right?
Right. Sorry.
Yeah.
Thank you.
Yeah.
So, Aditya, am I audible?
Yeah, you are audible. Please go ahead.
Two things I would like to achieve is like one, uh, migrating the data from the one source to another source. That's the one goal that I would like to achieve. Another thing is a data sync, creating the events on the primary database those are SQL databases. So, would I be able to do this after this course?
First is getting data
That's
loaded from
real time.
uh-huh.
Sorry.
Sorry, can you go ahead?
So two things can I achieve after this course? Migrating the data, I'm having a huge data on some source databases. So I want to migrate it to the target databases. That's the one course of action I would like to have. And second is I need to create event triggers on the primary database, which will sync me the real time database. Like for the user using the application and some source application which is having source database. So I want to have that when the user saving something, I have to have like a target database and target application of target database. So is this possible in this kind of scenario after this course?
Yes. So scenario 2 probably is already showed in the demo. It's a example, right? It's not a full-fledged, but you can get a hint that it's a trigger. Lambda is getting triggered by an event which is happening through a banking app, and the user information is then transformed and finally loaded to the real-time database itself, right? So you can get a sense that this is already being covered in this demo itself, and we are going to unfold this further when we go along in our sessions. Second thing is moving the data from static, not static, but on-premise source to cloud source, right? So this can also be done. There are various tools and techniques that we can do. So we can use those tools and techniques and discuss. One example I can talk about moving this data.
This is having the complex data structures. Can we achieve that?
Yes.
Let's say we have the databases, the data structures, the table. It has been linked to the some let's say 5 to 6 tables.
Sorry, I couldn't follow the last line because of some noise. The complex structure, I got it. What was the last line? It linked to?
One table linked to the some, let's say it is the code is written in the form of a tree data structure or the graph data structure. So where data has been stored in the where it has been linked to the 2-3 tables of at max it goes to even to 6 tables like that. Can we achieve the data migration kind of real-time scenario?
Okay.
I would like to have that.
Okay. So there are two things. One is data migration, and second thing is how do you populate this data in real time, right? So data migration will not happen in real time, never, right? Because you have large scale data. So this will happen in a frame of 1 day, 2 day, 3 day, 4 day, depending upon the size of the data. So your data predominantly will lie in a on-premise server. It can be in a DB, it can be in a form of a files that are stored in on-premise server. So there are different frameworks, there are different techniques that we use to move this data from on-premise server to a cloud. Now the question is in which cloud storage we are going to store this data. Are we going to store this data in S3? Are we going to store this data back in DB? That we have to discuss. That we have to discuss and see which is the best.
Completely between the database to database itself. The interaction completely one chunk of we are lifting and shifting it to the target database.
Yes.
So
there are tools, AWS tools that are used for that. Directly, you can use those tools, AWS migrate, and this can be done. It's pure and simple.
Okay, fine.
Yep. Okay. Any other last question?
Hi, so are you going to cover? Hello.
Yeah,
sorry. I joined it late. I had to. I was somewhere away. Just wanted to re-clarify. Are there any prerequisites to join this program?
Okay. I would not say any prerequisite, but basic understanding of I would say if you have a basic knowledge of SQL, that should be fair enough to move along with this course.
Okay, thanks.
Yeah, Vamshi, go ahead.
Yeah. So are you going to cover machine learning algorithms as well in
No.
this course, like how to deploy ML models and all that?
No, Vamsi. This is not basically in the agenda of this course. That's more of
Okay, okay.
MLOps work. That's altogether a different course, right? This will not.
Yeah.
Yeah.
Okay, okay.
But if you want, we will be having those courses. If you want to, you can enroll to those courses and we can take care.
Sure, sure. Okay. Thank you.
Anyone? Bharadwaj?
No, as of now, nothing. This is a completely new platform for me, so I'm just listening the demo class.
Sure. I'll give you a call tomorrow, everyone, so we can talk about other things as well, about the start date and about the timings and everything. Then we can see that.
Okay. Thanks everyone for your time. Hope to see you soon. Bye bye.
Thanks.
You bye.
Okay.
Have a nice day.
Thank you.
Thank you, Tal. Thanks for your time.